to Solar Alberta's 2022 seminar series. Today is the last webinar of our series, and it's called Ingredients of Alberta's Largest Urban Solar Project, PPAs, Planning and More. My name is Heather McKenzie, and I am the Executive Director for Solar Alberta. I'd like to take a minute to acknowledge that I am presenting to you today from Amiskwaciwaskahagan, also known as Edmonton, Alberta, Canada, which is located on Treaty 6 territory and the homelands of the Métis Nation. Treaty 6 territory is the traditional gathering place and home of many Indigenous nations, including the Papaches, Nahewa or Cree, Saulteaux, Dene, Blackfoot, and Nakota Sioux, nations whose ancestors have cared for and nurtured these lands since time immemorial. We were delighted to have so many people register for this event. Please note that we're recording the event and we'll be making it available on our YouTube channel in the future for your viewing pleasure. Today, we're going to be hearing from 3 informative speakers about the elements of the Barlow and Deerfoot Solar Project, which is the largest urban solar project in Western Canada. The session will begin by providing an introduction to Alberta's unique power purchase agreement market, also known as PPAs or virtual PPAs as well. I hear people say VPPA, so I'm sure we'll hear about all the different acronyms that enable many large solar projects, such as this one, to go ahead in Alberta. Following the presentation, there will be a Q&A period in which you can all participate. The formal Q&A will run until about 1/4 past the hour, and then we'll be inviting you to join us for an additional 15 minutes Q&A in a more relaxed Zoom meeting format at the end. The extended Q&A will be posted in the chat at the end of the formal Q&A, so I'll draw your attention to it at that time. Please make sure to click on the link for the Zoom meeting before leaving this webinar. The entire session will wrap up in 1.5 hours. In an effort to increase accessibility to the content that we're offering, we have enabled closed captioning for this presentation. You can turn the captioning on in the toolbar at the bottom of your Zoom screen. During our formal Q&A period, we will be using Zoom Q&A for questions rather than the chat box. So please enter your questions in the Q&A section. Also, please click on the little thumbs up symbol to upvote questions that you like. Before we move forward, we're going to do a quick poll to get a sense of who we have joining us today. So please take a minute to answer the question that should be popping up on your screen shortly. There it is. So what option describes you best for this audience? Are you a solar industry professional? Or you could include any green building professional in there, a student, someone who's solar curious. Sometimes we call you solar enthusiasts. Feel free to let us know. It's always good to get a sense of who's joining us. And while folks are still doing the poll, I encourage you to take a minute. Please pop your name, land acknowledgement, and any contact info that you're comfortable sharing in the chat now and also throughout the event. We really want to encourage you to use the chat for networking. Folks could look you up on LinkedIn or share your email if you are willing. It's nice to make sure that some relationships begin to be formed through this, this type of event. All right, thanks so much for participating in the poll. Very helpful to get to know a little bit about you. So it looks like about 55% are industry folks, 40% are solar curious, and we've got some students in the room too. So wonderful. A nice mix today. So we should have a very informative Q&A. Thank you. All right. Stop sharing of that. All right. Now I'm going to share a little bit about Solar Alberta, just in case you're new to our events. Solar Alberta is now in its 31st year of operation. We are a not-for-profit society that is dedicated to accelerating Alberta's transition to a just and sustainable energy future. We do so by advocating, educating, and serving as an industry and community hub for solar energy. Our membership is made up of over 350 individuals and businesses. We provide a number of services, including managing a solar directory through our website. In this way, we act as a bridge for installers, suppliers, and other solar-related businesses to connect with their customers and clients. You can see a screenshot of the directory here on this slide. In addition to our website services, we run a number of educational programs such as this solar seminar series on a number of Thursdays over the lunch hour throughout the year, as well as new multilingual Solar 101 workshops. We also host an annual online conference and trade show called the Solar Show, and a couple of in-person networking and trade show events each year. Please save the dates of February 6th through 10th for our 2023 Solar Show. Really excited to be offering sessions about community generation, electric vehicles, building equity in the solar sector, embodied carbon, and much more. Recordings of 2021 and 2022 Solar Show sessions can be found on our Solar Alberta YouTube channel, and a few of the workshops are also as a paper download on our website, solaralberta.ca. This fall and winter, we're hosting a number of live online courses at very affordable rates. I think they're often about a quarter the rate of sort of a for-profit course providers. These are for mostly solar industry professionals or those who are trying to transition into the sector. Classes are on Tuesday and Thursday evenings. If you're unable to attend the live classes, don't worry, we have also got the pay-per-download sort of pre-recorded courses and workshops that you can download on our website. So here's just a listing of what we still have yet to come. If you're not already, I'd like to encourage you to join Solar Alberta as a member. We are constantly evolving our member service offerings, some of which you can see listed here on this screen. Individual membership is just $35 and can be purchased at solaralberta.ca. If you're looking for additional ways to support the work that we're doing, please consider volunteering or donating. Many of you in attendance have already donated to Solar Alberta when registering for this event, and we just want to express our sincere thanks for that. Please be aware that volunteers are eligible for free membership with Solar Alberta after committing 15 hours, and they're also eligible for $100 off one of our courses each year. Volunteer opportunities consist of helping with communications, public education, advocacy, and much more. And now I want to take this opportunity to give a big shout out to our sponsor today. ATCO has sponsored today's event, and we're really happy to have their support as an ongoing corporate sponsor member of Solar Alberta. Really looking forward to learning from their expertise today. We're always interested in developing more partnerships and sponsorships for our events. So if your company would like to work with us to educate the public about solar or solar related technologies, as ATCO is today, please don't hesitate to reach out. For the 2023 Solar Show, we have already sold out of our illumination sponsorship and 3 of our solstice or sunshine sponsorships, but there are still 3 left. So it's not too late to jump in and be involved with that show. And now, without further ado, I would like to introduce our wonderful speakers today. Today, you're going to hear from Calvin Ng. Calvin is currently the primary analyst supporting Business Renewable Centre Canada, an initiative of the Pembina Institute. Calvin graduated from the University of Calgary with a Bachelor's of Commerce, with a concentration in energy management and a certificate in sustainability studies. He worked at a solar installation company, KCP Energy, as a project and sales coordinator. His subsequent role was a sustainability analyst with ETCH Sourcing, a procurement services provider specializing in strategic sourcing and category management. While there, Calvin developed supply chain procurement roadmaps combined with the UN Sustainable Development Goals, the SDGs, to create a comprehensive database for industry-wide use. Calvin has a passion for renewable energy, which was already shining through during his undergraduate days when he presented research on Alberta's grid called A Deep Dive into the Possibility of Utilizing Natural Gas as a Bridge Fuel to a Renewable Future. So thank you, Calvin. We're looking forward to hearing from you today. Our second speaker is Jody Dawson. Jody has extensive experience helping clients to evaluate and implement innovative solutions that drive true business impact. Over a career spanning almost 3 decades, Jody has led teams in the telecommunications, IT, agriculture technology, and energy industries to deliver value to customers. Jody also spent 5 years leading community and economic development initiatives in her hometown, following the 2013 flooding in southern Alberta. At ATCO, Jody is focused on bringing energy solutions that make a significant difference to other utilities, commercial enterprises, and communities. So welcome, Jody. We're looking forward to hearing from you today as well. And our third and final speaker today is Garrett Lubke, and Garrett's passion lies in developing clean energy for the world in a financially profitable manner. Throughout his career, he has managed projects throughout their lifespan, including customer interface, engineering design, proposals, coordinating engineering consultants, and permitting into procurement and project management during installation. The majority of Garrett's career was in oil and gas, including multiple jobs overseas in Holland and the North Sea. Since then, he has worked for Inferno Solar, providing the project manager and Southern Alberta manager role. He is currently a development engineer at ATCO. As an avid outdoorsman, it was a road trip to Alaska that really turned his focus into what he could do to help the planet. Every single glacier he and his wife camped by had receded by a major factor, and that was unacceptable. This trip showed him that the largest leverage he has on affecting climate change is not picking up garbage in Kananaskis on the weekends, but in fact is dedicating his engineering assets to removing hundreds of thousands of tons of CO2 from being produced. He believes the path forward for solar, wind, electric vehicles, and an overall green grid is an irrefutably bright future. And he wants to be a world leader in creating large-scale projects that make the world a better place. So welcome, Garrett, welcome all of you, and thank you for joining us today. I'm now going to turn the mic and the camera over to Calvin to begin our seminar today.
Excellent. Thank you, Heather.
Thank you.
I'd like to take a moment to I'm coming to your homes and offices today from the Treaty 7 territory. I'm based out in Calgary, and this is the home of the Blackfoot Confederacy, Stoney Nakoda First Nation, and the Tsuut'ina Nation. It is also home of the Region 3 of the Métis Nation of Alberta. I encourage everyone to find out your Indigenous territories and treaties as we are working towards reconciliation together. As a group here in Pembina Institute and the Business Renewal Center, as well as Jody mentioned earlier, in Treaty 6, which is located in Edmonton. So moving along, today I will be talking to all of you about how the corporate power purchase agreement works here in Alberta. And I believe the Q&A session is, like Heather mentioned, said later on in the presentation. So please do save your questions to the very end, and let's get going a little
Sounds
bit.
good. Hey, could you actually share your screen first? Because I think mine is still up there. So just wanted to, don't want to interrupt you, but I think if you could steal the screen, feel free to steal it.
Let's see here. My apologies. Realize I did not. There we go. Everyone should be able to see it now. Perfect.
Thank you. Okay. See you soon, Calvin.
Excellent. We are. So first, I want to give a bit of introduction about BRC Canada, the Business Renewal Center of Canada. We are an initiative of the Pembina Institute, and what we do is we simplify and accelerate large-scale renewable energy procurement across Canada through power purchase agreements or virtual power purchase agreements. And since we are an initiative of the Pembina Institute, we are a registered charity. We are not energy brokers, and the majority of what we do is provide educational services. We develop internal capacity for buyers that approach us through education and raising awareness of what PPAs are, and provide support through the procurement journey for buyers that are just learning about what green electrons, what RECs, what PPAs, and this industry, what they can do to help them meet their ESG commitments. And we offer cost-effective tools, services, and training like webinars and buyers boot camps throughout the year to help our members and help businesses understand what PPAs can do for their businesses. I would also like to share that in recent year, back in 2021, we had unprecedented growth in BRC. We saw a huge upspike in corporate renewable energy procurement, as you can see here in the graph. And when BRC was originally first established, we had the goal of achieving 2 gigawatts of renewable energy procurement by large-scale non-utility businesses. We actually breached that goal earlier in June of this year. So later in December, we're actually announcing a new goal and new target for 2030. With all the constructions, projects, and announcements to date, the PPA market actually support up to $3.75 billion worth of valuation, and also supporting 4,500 jobs. And we see this as more projects get announced as we move into 2023, and we see the trend for renewable procurement from all varieties of industries going in an uptick. So it's a very exciting time for corporate renewable energy procurement. Our organization consists of 3 different groups of participants. There's buyers, developers, and intermediaries. All of them are very important in making what we do work and making the network as strong as it is. So I highly encourage you to take a look at what we do if you are interested more about PPAs after the presentation today. So onto the main course. What is a PPA? What is a virtual PPA? What is a power purchase agreement? To start, let's talk about some of the renewable energy procurement opportunities that exist here in Alberta, and of course in other areas of Canada as well. First on the list, you can see that there is on-site solar. For the most part, this option is for folks with a large amount of real estate, usually industrial sites. Projects that is built on the site are usually for direct use, or companies can use it to export the energy that they produce, depending on what the project is for. And then the second on the list is unbundled RECs. RECs are renewable energy certificates. This is, I would like to say, is more of a first step, the baby step, into actually full-scale procurement of green electrons. That's because unbundled RECs really is just a purchase of the environmental attributes, and it doesn't necessarily support new projects that is being developed. And the third one there, you see green tariffs, which is places where there are more vertically integrated markets, unlike Alberta, which is a more deregulated electricity market. Green tariffs is essentially programs where institutions and companies can go to their utility to make a purchase of renewable energy or credits through that tariff program. And it also incentivize the build out of new projects. But the main thing we're going to focus today are, of course, large-scale off-site VPPAs, power purchase agreements. They can be not co-located with the purchaser, so the developer and the buyer can be in different locations, and it can happen through either the physical or virtual means. So essentially, the purchaser of the power can take ownership depending on how the contract of the VPPA is structured, and then the virtual purchaser can leave the generator to handle the electricity market side of things. So they will take care of where the electricity goes. There's no actual physical exchange of those electrons, and that's why it's called a virtual power purchase agreement. Going a little more in depth here, what is the actual agreement itself? And as you can see, it consists of really 3 core things. One, the contract, the virtual power purchase agreement establishes a fixed price the buyer will pay for every megawatt hour produced, either from the solar farm or the wind farm. And the buyer receives a renewable energy certificates for every megawatt hour produced. And these contracts are usually a long term. It can be 12 and up to 20 years that's backed by the buyer's credit. And to give it a little more insight, the VPPAs is commonly utility scale, as I mentioned earlier, so it's much larger than the traditional solar array on rooftops that you might have seen. So when the VPPA establishes a fixed price that the buyer is going to pay for every megawatt hour, it is not so dissimilar from when you enter into an agreement with a utility, especially if it's a fixed price contract. So you have some line of sight as to what you're paying for this electricity, and in exchange for that fixed price, you're essentially, the buyer is receiving 2 things. One is the renewable energy certificates, as I mentioned here, that is generated along with the megawatt hours that's being produced. That represents the renewableness of like the power that you're purchasing, because it is green electrons. And depending on how the contract is set up, either physical or virtual ownership of the power itself, in the market here in Alberta, you have a deregulated energy market. So the power is sold into the overall market, into a balancing pool, and it receives a certain price. And so you sort of have this price differential between the fixed price that the buyer is paying and the value of the electricity in the market. And what makes this a power purchase agreement is that the long-term contract, the 12 to 20 year, depending on how the contract is set up, especially depending on the operations or the needs of the company, being backed by the buyer's credit, the credit worthiness of the buyer helps to fund new renewable projects and to bring down that total cost of capital that ultimately gets the project built. I'm going to go into a bit of a diagram to explain further how this relationship works in the overall system. So there's a lot of lines here. I realize that, so I'm gonna try to walk through and hopefully give you a bit of a sense of how things actually flow. So as you can see here, we have three different players here. On the left-hand side, you have the electrical utility. That's the utility that you typically interact with as a buyer. And then you have this non-utility buyer here on the right-hand side of the diagram. It could be a corporate buyer, it could be an institution, or it could be a municipal city that is procuring that energy. And at the bottom of the screen, you see the renewable energy project. So without a virtual power purchase agreement, you really would just have that one thick line at the top there, where it relays energy from the electricity utility to the non-utility buyer. And that one orange line is what usually happens. And the purchase of the electricity, where you're getting your electricity delivered to your site from a VPPA, is that vertical line you see here, where when you bring in the renewable energy project, so as it generates energy, it feeds into that thick line at the top, at the orange. So when you add the VPPA, you're going to be enabling this renewable energy project to be built, and the project is going to be providing electricity there. As far as the pricing, you have this, again, fixed price contract that the non-utility buyer is promising to pay, but they are receiving the market price that the renewable energy project is generating. So essentially, at the end of the day, those two get netted out, and the non-utility buyer is really responsible for that price differential. And so if a fixed contract price is below the market price that it receives your power, then you're making a payment to make up that difference. But if the fixed contract price is above the market price, then the non-utility buyer is actually receiving effectively a payment. They get the upside of the price difference. I think some key things to remember here is that you're not changing the fundamental relationship with the utility, but you're really sort of adding on this piece that is the purchasing of renewable energy. And the cost of that renewable energy purchase depends on whenever the fixed price is that you agree on the VPPA, as well as what happens in the price in the market. And now, if you are someone who is using electricity in the market, you are essentially creating a hedge through your VPPA. And again, so price market goes up, you're paying more for that power, but you're actually going to be getting a payment out of your VPPA. But if the price of the power goes down, you might be making a payment into your VPPA, but you're also benefiting from those lower power prices. So that is how essentially it works, and how those electrons are transferred, and how it all flows. Moving on, I want to talk a bit about the benefits of a VPPA and why companies choose to procure green electrons this way, and choose to procure directs and environmental attributes this way. So key benefits listed out here, of course, is the renewable energy certificates. Secondly, is the additionality. Additionality is meaning new projects, new builds in the market that is happening. And then, of course, the potential positive projected settlement value, the savings that you'll be getting with the hedge. And then, of course, with operational flexibility as well, not like on-site projects, or not like bundle recs or green tariffs. VPPAs offer a lot more flexibility as a financial contract for companies. And to go a little more in depth, we think about benefits of power purchase agreements in many different ways. There is one that I would like to touch on a little further, and that one is actually additionality, because it actually goes into the whole environmental attributes conversation and how it goes into offsets as well as a RECs. So in the next slide here, I will break down what environmental attributes are and how it actually separates into the two. So up here, you can see that it can be, depending on how the contract is structured, go two ways, one as a REC, and then the other is carbon offsets, depending on what the buyer chooses. So for a REC, one REC is generated per 1 megawatt hour of generation by the site. It is creation is tracked and managed by third parties. Commonly, the two companies you might have heard of is Green E and Ecologo. Many projects in Alberta and Canada is actually managed by Ecologo, while many in the States prefer Green E. Voluntary buyers of RECs can purchase a national Green E RECs. And again, Ecologo, Green E, depending on where you're operating as a company. And they're both organizations that essentially manages the RECs. And then on the carbon offset side, you can see here total carbon dioxide equivalent by, so essentially carbon dioxide, carbon offsets is measured by the tons, megatons of carbon of CO2 that you're not emitting, and the conversion rate is based on the assumed displacement of thermal generation by the renewable energy generation of the site that you're procuring the power from. And carbon offset can be calculated, and I'm going to share a bit about how it is calculated. The offset is usually valued hour by hour, and the conversion rate of the carbon offset is based on a yearly average. Here in Alberta, there are two ways carbon offsets are usually generated. One is through the true offset calculation, which offset protocols tries to approximate the displacement of how much you are actually displacing in terms of CO2 by megatons. And then the second is a third-party group, OBPS, which is the carbon pricing system that we have in place, where emission performance credits can be directly granted. That is more related to the system itself. Compared to RECs, which is a little different, RECs is more for enabling and also granting companies the ability to say that they are operating using renewable energy. And there's two markets that it usually falls under. One is compliance and one is voluntary. In the compliance market, companies can choose to lock away their renewable energy certificates, retire it to claim those benefits, or RECs can also be sold on the voluntary market by companies to other companies that may need it as well. So kind of similar to what I was mentioning earlier, one of the procurement options is unbundled RECs. But again, just the purchasing of RECs doesn't actually support additionality, tying back to the earlier slide, which is the new build and new projects and new green electron sites being added to the grid into the market. So a few things I wanted to make a note here. How energy provider can sell carbon credits is not sold through the PPA. This is where the additionality can really be claimed by enabling projects to be generated, and keeping the offsets from being sold or monetized is where the renewable additionality really comes from. I'm going to take a quick pause here. I know that was a lot of information, so I'm going to take a quick pause, check in the chat, but essentially that is a very high-level quick summary of what PPAs are. I highly encourage you to reach out to us here at BRC if you would like to learn more. And if there are nothing from the participants, I will pass the mic off to Garrett from ATCO to share a bit about his project and his presentation.
Thank you, Galvin. Hello, everyone. Welcome to the Solar Alberta webinar. Today, we're going to be talking about the ingredients of Alberta's largest urban solar project, power purchase agreements, planning, and more. My name is Garrett Lupke. You just heard from Calvin Ng, and we will have Jody Dawson joining after myself. On behalf of ATCO, I will be presenting on behalf of ATCO Power and Renewables, focusing on the development and the owner-operator perspectives. Jody Dawson will be following me, and she'll be presenting on behalf of ATCO Infrastructure Services, which is our design and EPC business unit. ATCO is a remarkable story. What started with humble beginnings as a little trailer rental business has grown into a truly global company, leveraging long-term investment across essential services. ATCO celebrated its 75th anniversary this year and continues to grow into the future. This growth spans the Americas, Europe, and into Australia. The growth we're focusing on today is in the renewable generation market. In 2019, ATCO concluded the sales of its coal and gas-fired generators to fully divest from fossil fuel generation. The next step was to move into renewable generation. ATCO, through its investment in Canadian Utilities Limited, acquired 2 solar installations in Calgary aimed at producing clean, renewable energy to power Alberta's grid and support the transition to lower carbon energy. In addition, we have a 3rd solar project currently in construction near the hamlet of Empress. On October 5th, 2022, it was announced that ATCO had entered into a definitive agreement, which will bring over 200 megawatts of operational wind generation and 1,500 megawatts of renewables development into our portfolio. This is expected to close Q1 2023. Getting back to the focus of this, these solar projects are examples, previous slide, please. These solar projects are examples of how ATCO is providing our customers with the opportunity to decarbonize their energy consumption. There are also prime examples of the kind of opportunities ATCO will continue to pursue as we grow our portfolio of renewables. ATCO is delivering on our strategy to help customers and communities across their transition to clean energy in a safe, affordable, and reliable manner. Before discussing the projects, I want to acknowledge that we live and work on Treaty 7 land. Working closely with Indigenous communities is a core value at ATCO. While the relationships have been growing for decades, the projects I want to highlight include the Fort Chipewyan Solar at 3 megawatts between phase 1 and 2, as well as the Old Crow Solar project, which is around 1 megawatt. The Barlow and Deerfoot projects are no different, and we are currently undertaking confidential commercial discussions to bring value to our Indigenous partners through these projects. The Barlow and Deerfoot solar projects will be the largest solar installation in a major urban center in Western Canada. They come in at 27 and 37 megawatts respectively. Together, the installations will have over 170,000 bifacial solar panels. Bifacial panels produce solar power from both sides, which results in up to 30% greater energy generation. The 2 installations combined cover the equivalent of roughly 170 Canadian football fields. You can go next slide. Together, they will generate enough renewable electricity to power more than 18,000 homes and offset 68,000 tons of carbon a year. It's worth noting that these 2 projects are engineered to be ready for future battery energy storage, as future build-out can reduce the common concern around the intermittent generation that solar projects can create. Projects of this magnitude do not happen overnight. The landowner and the project developer developed these projects for 4 years. ATCO purchased these projects in Q4 of 2021 as a late-stage acquisition. We took roughly 6 months to get ready for mobilization, and now both projects are currently in construction. Expected commercial operation date for Barlow and Deerfoot are Q2 and Q3 of 2023, respectively. Of course, projects of this magnitude, next, Jody. Projects of this magnitude also don't happen without the capital needed to construct them. A powerful mechanism used in renewable project development is a power purchase agreement, or PPA for short. Calvin explained PPAs in depth earlier in this presentation, but in essence, they are a long-term revenue contract that allows project owners to finance construction based on that guaranteed revenue. Earlier in 2022, ATCO and Microsoft entered into a 15-year power purchase agreement for the entirety of the Deerfoot project's generation. The crux of this project is that the land is a remediated phosphogypsum landfill. With guidance from Alberta Environment and Parks, the landowner capped these landfills from 2007 to 2009. This picture is from 2002, which shows the layout of the two landfills used for the fertilizer byproducts. Top left is the Barlow project, and bottom right is the Deerfoot project. The cap that was placed on top of the phosphogypsum is a clay layer designed to mitigate the environmental hazard. This land was dormant for about a decade as it was considered undevelopable until the landowner and the project developer had the vision to create a solar project on top of these landfills. Due to the environmental risk posed by these fertilizer byproducts, the site does come with restrictions. The primary one being that you cannot pierce the clay cap. The result of this restriction means that we cannot use piles on the fertilizer stack. Piles are a mainstay of utility scale solar generation projects. So what did we do to get around that restriction? The solution to this problem was an in situ concrete ballast designed by Polar Racking and PRI Engineering. The concrete ballast has been designed to minimize the pressure exerted to the clay cap. While the volume of concrete used on these projects is significantly higher than a conventional solar project, this is offset by the elimination of piles supporting the solar racking. Precast options were considered, but minor undulations across the project site created an alignment risk from ballast to ballast, and overall, it was decided that an in situ solution would be the correct solution. As with any solar project, wind loading and uplift was a consideration, and the volume of these blocks do vary across the site. Looking forward, ATCO is driving the transition from fossil fuels to cleaner, lower carbon energy solutions. Our growing renewables portfolio, including these two major urban solar projects, is a key part of that transition. This concludes my section of the presentation. The fabulous Jody Dawson will take it from here to present ATCO Infrastructure's role in these projects and beyond.
Thanks, Garrett. Sorry, one moment. Wonderful. So good afternoon, everyone. We've heard about some of ATCO's exciting projects. Now we're going to focus our attention on yours and how to move those forward. The team I'm part of, as Garrett mentioned, at ATCO, works with communities, companies, and developers to support them in building small-scale to very large-scale renewable projects. I imagine that many of you attending today are at very different stages for your projects, and maybe you're just dreaming at this point. But for the purposes of this presentation, we're going to start at the very beginning. Renewable energy solutions are a long-term, typically large investment, so we recommend taking a phased approach, making a series of smaller investments, leading to the best possible approach for you. We're going to have a look at these phases and a little bit about what you can expect in the 10 minutes I have. Regardless of the scale of your project, the basics of these phases will apply. Like with really any investment, the best place to start is having a clear goal. This is particularly important for communities that are considering a renewables project when there's so many stakeholders involved. You might already think that solar is the best solution, but before going too far down the technology path, it is worth spending some time getting clarity around what you're looking to achieve. Maybe your focus is on increasing energy reliability, decreasing dependence on fossil fuel, effectively using a piece of available land, increasing the efficiency of energy use, or it can be all of those things. Once your goals are clear, you can move into designing the best solution and then ultimately build it. As you progress through the phases, you can see that a greater percentage of the design is completed. From a dollars perspective, the money you need to invest to move through this funnel, you can expect to spend more. So there's an inverse relationship with this picture. And then if you're looking at funding, you may have to make an investment to a certain point to get the financing in place for the next phase. From a time perspective, the amount of time that each of these phases is also grows. And as Garrett just shared, it can take anywhere from 2 to 4 years to move through these processes. So let's take a little bit more detailed look at these phases. At pre-feasibility, you're really taking a look at the viability of what kind of technologies might work for you. You're determining who you might want to partner with to help and what capability you already have inside your organization or community. You're gathering the requirements, taking a look at suitable locations for projects, looking into funding if there is some. There is some great funding out there for some parties right now, leveraging any previous studies that have been completed to date, and identifying high level cost benefit. As you move from pre-feasibility further in the design, I'm going to talk to you a little bit about the engineering work that's happening. So once you've completed pre-feasibility, you'll typically have identified a solution or set of solutions that are best suited to meet your needs, which will include the technology and the most appropriate location. So again, for today, we're going to talk about solar. The feasibility and feed stages drive out the more detailed design, obviously, of the recommended solution. A firm like ATCO will have a proven process. We know the key considerations, we have this past experience, and the right expertise can help assure the most effective use of your investment dollars. Solar, or the PV design, constitutes the major portion of the facility design, and it will include the electrical design, the single line diagram, the layout, geotechnical, the survey of the land, the civil, the foundations, the pilings, the rackings, and all those other pieces that are required. Moving to the right, the balance of plant. Although the medium voltage portion is small, it can be the tricky piece. The sizing of the medium voltage gear and the tie-in to the distribution facility owner or the utility that you're connecting with for the grid is often a time-intensive process and requires extensive coordination and collaboration, which is really another good reason to find an experienced partner. The interconnection engineering helps understand the distribution facility owner and the transmission facility owner in the region and how you need to connect to it, what the regulatory requirements are that need to be fulfilled. And these requirements, of course, will often affect the decision-making on sizing of your power plant. On larger utility scale projects that we've been involved with, sometimes developers will involve 2 separate engineering firms to design the solar PV side and the balance of plant, depending on the expertise that they're looking for. And of course, on the very far side, obviously there are wildlife and a lot of environmental considerations that need to be evaluated and planned for within this designing process. As you move through the funnel, expect your design to evolve, going from the conceived design to an actual execution. As you start learning about constructability, it will uncover constraints and your solution will need to adapt. So let's pause before we move into the tip of the triangle, the engineering, procurement, and construction phase. Let's take a moment to review a couple of case studies. So I'll start actually with a community level one, as Garrett had talked about some of the utility level ones. Now in this case, in central Alberta, there was a pre-feasibility identified solar as the best option. There was a desire for a utility scale renewable solution. At pre-feasibility, all possible technologies were considered, but the recommended facility was a solar facility of just under 5 megawatts. Feasibility study drove out the more detailed design, reviewed all the environmental and geological details of the proposed site, along with all of the requirements involved with interconnection to the grid. This study identified that the proposed site can support the design and identified all considerations for implementation. In Southeast Saskatchewan, we worked with a corporation and a community where the corporation was using a piece of land owned by the community, and the company had a desire to implement a renewable solution for their purposes that also fit the needs of the community as well. So that goals conversation. Feasibility included identifying the supply and installation of material for a ground mount solar system, and investigated the cost to connect the project to the utility in 2 different scenarios. A full environmental assessment and geotechnical investigation were completed for the proposed site. The feasibility report also outlined all of the additional studies, permits, and approvals, which would need to be included in the development phase of the project. This, of course, along with a full cost breakdown of all the development costs, along with the proposed schedule, were also included at this stage. So now we've reached the stage to where we're getting closer to build. As you move into building your project, you will choose an engineering, procurement, and construction partner like ATCO, who will drive out the final design, all of those details, procure the required equipment, and construct the facility. From a high-level perspective, you'll want to determine right up front who takes the responsibility for ordering what, and understand any logistical challenges associated with the jurisdiction you're building in. Defining these things early on is very advantageous. In today's market conditions with some supply chain challenges, anybody out there who's building right now knows this, some equipment will take longer to procure. Some of these items include transformers, solar modules, inverters, large conductor, and cable. Delays can be avoided through early engineering and procurement practices, such as performing specific engineering in relation to the long lead items early, so orders can be placed. Early procurement of solar panels, piling, cable, etc., and partnering with an EPC that has large purchasing power and access to many vendors and markets can be very helpful. And now we're ready to build. The first thing to look at here is the construction process. Many activities can overlap during construction to maximize schedule efficiency and shorten the project duration. It doesn't actually have to be linear. If you only have partial funding in place, progress can be made on the site during those initial aspects, and then when more funding is available, the remaining can be completed. Of course, safety is paramount. You want a partner that performs work safely, has a long track record of safety and robust practices. You can have your EPC partner be responsible for pulling all the permitting, development, building, and electrical, or any other permits for your project within the municipality that you're completing the project. During construction, of course, a good EPC will be ensuring quality is high on the priority list. And then once your construction phase has been completed, the project will be operationally tested and commissioned. This ensures interconnection to the grid will be completed properly. Your EPC contract will be complete once the project is energized, and the last piece to think about is operations and management. An O&M plan will need to be developed and potentially a contract hired to support the life cycle of the project. So I know there's been a lot of information today. I'm grateful to have had your time, and I'll hand it back to you, Heather.
Wonderful. Thanks so much, Jody, Garrett, Calvin. Really appreciate that. If the 3 of you could turn your cameras on now, then we will move into the Q&A. Just a reminder to all of those attending that we're going to use the Q&A box for this portion of the event. Rather than the chat, it's just a little too tricky to monitor both. So if you could please post your questions in the Q&A box, should be in your toolbar on your Zoom screen. And if you're really having trouble with that, you can come through to the Zoom meeting room after and ask your question verbally. You can also upvote each other's questions, and I see some folks have already started doing that, so I appreciate that. And I think we should just dive right in. So our first question today is about, wow, this is an interesting question. I'm just going to read it verbatim because I don't actually know what all of these words mean. All right. Question, oh, sorry, the upvoting is resulting in them all moving around. This is fun. All right, I'm going to pause one and answer it live here. So this one is, how liquid is the Alberta PPA market? How is a fair fixed price determined? So Calvin, maybe do you want to start with that? I don't know how many details ATCO wants to give to their contracts. So maybe you can speak more broadly to this fair purchase price contract, as I know there's always a lot of privacy when it comes to contracts for companies.
Yeah, thank you, Heather. I'll definitely be leaning on Echo to answer this question, especially for the first portion, how liquid the Alberta PPA market is. In terms of visibility in pricing, as a charity, BRC doesn't get a lot of that data from our developers and buyers. But what I can say is that for the fixed price, so the contract fixed price for a PPA or a VPPA, that is determined between the buyers and the developers. Currently, the pricing trend we've been seeing for solar projects, the fixed price tends to be between the $50 to $60 range, while wind is a little higher, between the 60 to the 70. This obviously has many factors that changes how pricing is determined, especially inflation, the size of the project, materials, location, so on. Many factors are involved, but I'm going to pass the mic to either Jody or Garrett to answer a bit about the liquidity of the Alberta PPA market.
Sounds good. Thanks, Calvin.
Hey, Calvin, yeah, I can take this one. Obviously, with any confidential pricing information, I won't go into significant detail here, but as for the question to the liquidity of the PPA market, it does not vary as quickly or as significantly as the pool price. As people who have been following the pool price over the past few years have seen, it has escalated significantly. And due to the long-term nature of power purchase agreements, they do not follow that same volatility. And as Calvin said, dependent on terms of the PPA, the price will be a bilateral discussion between the seller and the purchaser.
Yeah, it's interesting. I think a lot of people are looking for some stability and reliability. So it sounds like a PPA really offers that during these tumultuous times. Well, thank you for that. And the next question here is about end-of-life costs. So are the end-of-life costs significantly different for the concrete ballast solution as opposed to piles? We definitely have some technical folks in the office in the meeting today. You want to take a stab at that?
Yeah, absolutely. Thank you for the question. It is a very well-rounded question regarding the life cycle of a project. And that is a greater discussion about the whole renewable industry as well. As far as the concrete ballast, we did an analysis on the end-of-life costs. And as you can understand, the variability of those costs in 25 years or 35 years time is huge, but we forecasted that the end-of-life costs would be in the same magnitude of order, and it provided a competitive LCOE for the entire project as opposed to.
Interesting. Yeah, we've been getting a lot of questions about end of life when it comes to solar PV, and we've been having some good conversations with the Alberta Recycling Management Authority about their plans for reuse and recycling in Alberta. But I hadn't really thought about it with respect to the ballast as well as the system that you're using. So it's good to kind of think of that end of life question for the full meal deal, not just the solar component of it. Thanks for that. So another question here is, what is the agreed quantum of solar power in PPAs? Oh, sorry, what if the agreed quantum of solar power in PPAs is not delivered during any PPA period? So I wonder if that is meant to say quantity of solar power. So I wonder if one of you want to take a stab at that. Basically, what if it doesn't deliver during the PPA period? How do you deal with that?
Calvin might add further insight to this, but from our perspective, that is a confidential agreement between the buyer and the seller, and that is contract specific. Right.
Yeah. A lot of these things are going to be contract law. I mean, it's kind of the same for any contract, right? So if you have a contract and it can't fulfill one side or the other, almost every contract out there is going to lay out some, this is what happens in these circumstances. So I'm not sure what that would look like, but Calvin, do you want to speak a little bit to some of those provisions and safeguards that might be put in place for a PPA?
Yeah, I'm not sure if I understand the question completely, but it kind of dives a little bit into how ASO operates, right? So our electricity operator here in Alberta, how energy is distributed is through a merit order. So technically speaking, the energy that is contracted in the PPA, the electrons will be delivered regardless. I think it's important to understand that there actually isn't a physical exchange of electrons through the VPPA itself or the power purchase agreement itself. It is not exactly how it works. So I'm just having a little bit of difficulty understanding exactly what the question is trying to pinpoint. But yeah, what Garrett say it would be correct. It would be completely dependent in the private conversation between the developer and the buyer and how the contract is set up. But if you would like to clarify your questions a little more, maybe I can give a bit more insight, but I
Yeah.
hope that helps answer it.
Well, that'll be the benefit to our Zoom meeting at the end of this, is if we could get into some more clarity as well for the audience who's here. But yeah, I think you have answered the question. There is that virtual element, so it's not a literal transfer of electrons. So I think that is very important, and the ASO or the ISO is monitoring all of these inputs very closely. So thanks for touching on that. Oh, good. Someone's asking about energy storage. I was going to go there if they didn't, but of course, energy storage is all the rage these days. I was at a presentation recently where someone said that it's hard to find any large wind arrays going in without solar automatically added on. And I saw you were putting aside some space for storage here with the solar array. So Ken's wondering what type of energy storage systems are being considered for the solar parks. And I know ATCO has done solar storage before, so maybe you could speak to some of the types that you've used before as well.
Yeah, absolutely. Again, thanks for the question. As for what energy storage is being contemplated, of course, that is a larger conversation that's ongoing behind closed doors. Obviously, there won't be a large-scale pumped hydro facility on the site, but we don't know that answer yet. So
okay. And do you know what's been used in the past for ATCO's other energy storage projects, or?
Well, I can speak to the largest one that is in development in Australia right now. The Central West Pumped Hydro is a 320 megawatt pumped hydro facility.
Okay, so that's the system. Okay, thank you for that. We have a question here. Are there any insights to share if any Indigenous-led partnered projects have been able to secure power purchase agreements? Have power purchase agreement rates of Indigenous projects been higher so as to increase benefits to Indigenous communities who may be owners? That's a broader question, so I wonder if Calvin, you want to take a stab at that one?
Yeah, absolutely. And please jump in, Garrett or Jody. We are seeing some news regarding well, not usually procurement from the corporate and Indigenous ownership. We have seen one so far. Last year in 2021, there was a 150 megawatt solar project, I believe, between Synovus Energy, the Cold Lake First Nation, as well as Elemental Energy. That is currently the largest project to date, if my memory serves me right, where it includes Indigenous ownership and equity in the project. How it is actually structured, again, is between the buyers and the developers. So as a charity, we don't get a lot of insight as to what that looks like. However, the Business Renewable Center is seeing more conversations regarding Indigenous participation for power purchase agreements for renewable energy procurement. And we are working closely with the other programs within our organization, like Renewable Energy in Remote Communities, or IRC, to find solutions and ways for Indigenous participation in the future.
Yeah, thank you. Jody, Garrett, anything to add on that? I know ATCO works with a number of Indigenous communities, as you mentioned, but I think Calvin did cover quite a bit there.
Yeah, I think there is a lot of benefit from all parties with Indigenous ownership. And I think it's something that, you know, not just ATCO, not just BRC, but everybody in the industry should be considering and acting on.
Yeah, thank you. So question here, is there a strategic plan or central planning at the provincial level for siting of renewable projects? I might touch on this myself just to begin. For those of you who aren't aware, we actually have a keynote speaker coming to the solar show this year from the Alberta Electricity System Operators. So we have a VP there coming to speak on February 6th. So talking about their path to net zero. And so that might be a really great question to pose to the ISO themselves. But yeah, so strategic planning, I think, you know, Garrett and Jody discussed the fact that there are many hoops you have to jump through. This is a very heavily regulated space, just like with any power plant, right? If you were popping up a regular old power plant, you would have to jump through some hoops. And just like that, if you're popping up a solar power plant, you're going to have to jump through some hoops. So there is a lot of planning that goes in, and a lot of analysis that's done, and various studies. I think, Jody, you were mentioning all the different environmental studies, and there's transmission line studies, and, you know, do we have the capacity to take it on? From a very basic level, I will say, in terms of siting of renewable projects, the province does have a few recommendations for where to site projects. And brownfield, which is ATCO's using brownfield, so previously developed land that really can't be used for other purposes, is always strongly recommended. Solar Alberta recently launched our own solar siting recommendations that were informed by the province and other recommendations, so you can check those out on our website as well. That's specific to how do you choose your land. But I'm just going to turn it over to our speakers to discuss that a little bit further. Anything you folks would like to add about the strategic planning or central planning from the provincial level that's influencing sort of your path forward with these projects?
Yeah, I can speak to that. The ASO does have a energy storage roadmap that is currently out, and they are working on the next iteration of that, which is expected to come out, I believe, January of 2023. As far as the province citing the projects, it is a deregulated market, so it is up to the developers of these projects to acquire the land and site the projects. However, the ASO is undergoing a lot of studies, and especially as renewables have a greater penetration in Alberta's market, the frequency response and other grid servicing issues are coming to light. So the ASO is very cognitive that there will need to be technical replacement for the spinning reserve of thermal plants. As to siting of them, that's up to the private market.
Right. And I guess we should mention there are provincial factors at play, but there are also municipal factors at play, because municipalities determine land use planning and land use. So I imagine you also had many conversations with the city of Calgary about this as well, not just the provincial government, not all of which you can probably get into, but there's always hoops to be jumped through at every level of government. And with solar, you are using so much land that municipalities do often have a say in that as well. Well, thank you.
Sorry, yes. Heather, if I could just add
ahead.
that what's really important is just to be as familiar as possible of what will be required at each stage, so nothing's a surprise. That would be the piece of advice I'd give.
Yeah, and I think ATCO and a few other Solar Alberta members do provide advice as well for folks who are trying to go through all those hoops, because I've heard we had one workshop once that said it's $1 to $3 million and 2 to 3 years just to jump through the studies and all those things alone. And so that's before you purchase any of the solar supplies, if you're doing a large utility scale build as you have. So it's important for folks to realize things look a lot different at the solar farm scale than they do at the micro generation scale. So thank you for that. So Fred is asking Jody, it looks like more of a comment, but perhaps something for you to comment on, Jody. Vegreville is looking at a solar farm that would be adjacent to ATCO's operations in that community. So I think this is an FYI. Anything you wanted to touch on with respect to that?
No, I don't think so. I think that our services as infrastructure services are not dependent on where ATCO has facilities. So we
Yeah.
can have conversations with anybody in Alberta.
Interesting. Yeah, I think a lot of folks outside of ATCO sometimes get a little confused about who's doing what. And so if I understand correctly, Garrett is on the side of ATCO is literally building their own solar facilities, and
Correct.
you're on the ATCO side, which is we help and advise other people on how to build their facilities. So
Well done, Heather. Yes.
thank you. Yeah. I'm slowly, ATCO's been a member for a long time, so I'm slowly picking you apart and figuring it all out. But I'm going to become an ATCO interpreter for our audience, I think. It's good. It's good to know all the different things you folks are expert at. Okay, we've got another interesting question here. What if the transmission charges of utilities increase? Would the PPA rate change? So questions about other factors out there that might be less stable than we desire. Any thoughts on that point?
Yeah, I guess I can take this one. And again, feel free to jump in to add anything, Jody and Garrett. I think it's really important to note that as far as the pricing, because it is a fixed contract price, the utility buyer is promising to pay at that fixed price. So the relationship between the buyer and the utility that is providing the electricity, that doesn't change. So the fixed price, the PPA rate won't change because it is decided by the contract. So what happens is if the fixed contract price is below the market price that it receives for the power, then you're making a payment to make up that difference. But if the fixed contract price is above the market price, and also the market price is again determined by a lot of factors as well that can change it, but the contract price for the PPA itself will not be affected. It simply reacts to how the market price is moving, and then you benefit in different ways as a buyer, depending on how the contract is set up.
Yeah, I mean, ultimately the buyer is getting the predictability here, and the seller is taking the risk on the distribution and transmission costs increasing over time. I will say I was really interested. There's a lot of talk about D&T, distribution and transmission costs. I'm not sure how many of you follow Andrew Leach and his colleagues. They produce a bunch of energy reports through the U of A. And there was one interesting post yesterday by one of his colleagues, which showed the cost of distribution and transmission and then the cost of electricity. And the D&T really didn't factor much at all when you compare the two. And so I think that's probably based on maybe this one source I read. It seems like that's maybe the less risky factor. The higher risk factor is really what are the other inputs going to look like? But again, this is definitely not my area of expertise. Anything to add on that, Jody and Garrett? The question around D&T costs and how that poses a risk to sort of the developer.
I think Calvin covered it well.
Covered it well. Okay, good. Yeah, thanks for that. Okay, Joe's wondering. So Joe says, when is the Empress construction and COD? Will it provide energy to the nearby industrial plants? So I'm not sure if any of you feel prepared to speak to this one.
Yeah. The Empress Solar Project is slated for COD end of next year, which is 2023. And it will be supplying energy to the Alberta pool. So indirectly, yes, it will be supplying energy to those industrial plants. However, it will be flowing through the grid, and you can read as how you would like to interpret that.
Yeah, and so COD stands for sort of when it's live on the grid. What does the acronym stand for?
Commercial operation date.
So my audio cut out there.
Commercial operation date.
Thank you. Yeah, I always enjoy the acronyms, but I like to spell it out because there's got to be someone else like me watching who's wondering what does that mean. So that's great. Thank you for that. Okay, what is the grid parity if we see a solar project and a conventional source of generation? So we're looking for some comparisons here. Anyone want to touch on that piece? A little beyond the scope of our session today. I feel like I was like, ooh, that's a deep one. Should we bring that into another session, maybe a future solar show session? All right, Yogesh, we'll bring that one to another session. My staff will take note of your question. Sometimes when we get questions that are a little bit different than the topic at hand, we start brainstorming about our next seminar. So I don't mind when we get some interesting questions like that. Okay, Foster's wondering what lessons was ATCO able to apply these larger scale projects and to their EPC business from the conversion of isolated generation sites to solar, for example, Chip Lake. What lessons did ATCO, could they apply from their larger scale projects, okay, to their EPC business? Yeah, so I guess past learnings, how has that informed the decisions that you've been making on this project? Were you able to kind of leapfrog over some of those challenges of past projects?
I think as an owner operator for a lot of years, ATCO sort of already brings that to the table for projects. I can speak directly to when Garrett was speaking about the ballasted solution that we're implementing. We're looking at doing that in a remote community right now. So we apply design specifications, like we learn from every site. And I think it's obviously critical to acknowledge that every piece of land is different. So there's something to learn unique in every project, but we take all of those learnings forward.
Mm-hmm. Yeah, it is really interesting the different ground you build on and the different techniques you have to use depending on if it's rock or sand, or in this case, it's perfectly fine, but you can't actually drill down. So that was very interesting development. Okay, question here from Shannon. This one's for me. Do I know when the province will open up Crown land for solar development? There has been no word on that from the government of Alberta. I know there are many who are hoping that at least solar could be allowed where the oil and gas operations have been permitted. But right now there's no word from the government of Alberta that they're moving on that issue. So it's something we raised with them when we met with them a few years back, but they seem to have kind of held off on any regulatory change at this time from what I can see. We do have a section on our website called Advocate With Us, and we do have one provincial lobby there right now that you could check out if you want, but it's not the Crown land piece because I don't think there's as much openness to that at this particular moment, just because there's been so much controversy within the environment and parks side of things these days. So, so I think we have maybe more progress to be made on the microgen regulation right now. Okay, Garrett, let's see. Please, what is the size in megawatts of the projects 40 Mile, phase 1 and phase 2? Okay, what are the size of the projects you were discussing in megawatts?
We weren't discussing the 40 Mile projects. Those are in the 200 megawatt plus range, and they are listed in the ASOQ.
Okay, yeah, the ASOQ is always fun. Fun website reading. If anyone wants to nerd out with me someday, just fire me an email and I'll show you where to find the ASOQ. My staff enjoy nerding out with me there occasionally. I don't know if they would call it enjoy that, but that website is a wealth of information if you don't mind spreadsheets and whatnot.
I do enjoy surfing the ASOQ.
It's pretty amazing. The other day, it looked like by 2025, we're going to have 10 times the solar that we have today. So I have to double check my numbers, but it was pretty phenomenal, the build out over the next few years. So that is the fun part of the ASOQ. Okay, I'm going to ask one more question here, and then we're going to take the last questions over to our webinar meeting format so we can actually see some of these amazing audience members and wave at each other and be real people for a change. So I'm going to ask this one last question, then we'll take it over there. Thank you very much for the webinar. Could you please comment on the ROI the return on investment, for those who don't like acronyms, of solar projects. Commercial and residential is what the question is about. I can talk about that a little bit more in the meeting after, but I'm wondering, given that you folks are kind of solar farm experts, I am curious about this question from a solar farm perspective and the return on investment. You know, when do you anticipate starting to turn a profit for these sorts of things? Even just a ballpark kind of 10 to 20 years or 5 to, you know, I know you can't probably give specifics, but I am a bit curious on the timelines there. And we can touch on residential and commercial a bit in the Zoom meeting later.
Yeah, that's very project specific, and that is market specific, that is contract specific, that is, I'm not going to give a range. I'm not going to comment further than that, but as a whole, per megawatt hour utility scale is typically more cost efficient than commercial, which is more cost efficient than residential, because your price of the megawatts of the solar equipment can remain close to the same per megawatt, but a lot of the additional costs of a project, such as permitting and customer acquisition, if you're in the residential space, become a bigger portion of the project.
Yeah, and I think it's just really important for everybody to realize that when we're talking about big solar farms like you folks are today, we're talking about building solar for profit. Whereas when we're talking about commercial residential, we're capped. You can only produce as much as you consume in a year. So you're just building solar in those instances to offset your on-site consumption. So totally different kind of worlds that we're operating in, and the return on investment would be very different depending on whether you're operating as a for-profit enterprise, like as a power plant, as opposed to if you're just putting up solar to lower your utility bills. So very different scales, and I don't think a lot of Albertans are aware of those two scenarios. So thank you for touching on that here. So I see we do have some more amazing questions coming in, and we're going to pull them over to the Zoom meeting room.